Good afternoon. Thank you so much for joining us. Today we'll be covering Anthos Storage and how it enables seamless data management for Kubernetes. So we'll start with a quick set of introductions. My name is Manu, Batra. I'm the product manager for Anthos Storage for Google Cloud. Here with me is Oleksiy. He's part of the engineering team for Anthos Storage. And we also have representation from our partner team, Robin.io, and Partha will be covering some use cases around how Anthos Storage is helping customers around seamless data management. From the topics perspective, the areas we want to focus on is what really is Anthos Storage? What are the key use cases, key functionalities it is delivering? Getting into why we think it's a worthy challenge to be addressed. What are the challenges today with managing stateful workloads? And how we're enabling with partner ecosystems. So a list of what all partners we're working with and how we're enabling not just internal, but externally, how we're meeting customers where they are with the storage providers they're working with. We'll get a deep dive into the architecture pieces, getting into what all of the moving parts, how all they connected. And eventually, the most exciting part is going to be a demo, where you'll be actually able to see a couple of use cases around how we take snapshots and backups and rollback. So that's a pretty packed agenda, and we'll get started on this. So starting with what? What is Anthos Storage? The key goal we're delivering with Anthos Storage is we're providing enterprise-grade storage management functions for GKE workloads, whether those workloads are running on-prem or in the cloud. The goal is to be able to extend the consistent experience, the centralized control, agility, and flexibility that Anthos brings to the table to the storage layer. And to do that, we're working essentially where our goal is to provide customers with a consistent set of control plane interfaces, where independent of the vendor that they're using for the data plane, we want to provide a set of APIs and interfaces which are consistent. And to enable that, we're working with the community and our partner community also. So a set of partners, we're working to say, how do we engage and enroll them to get that interface adopted much more widely? So it's a much more broader effort integrating with community and the partners and providing customers with a seamless, consistent experience for stateful workload management. Now, getting into a bit more specifics about what are the key use cases, the key functionality sets we're planning to deliver. The first set of functionality is to enable stateful workloads. What we really look for is if I have to do storage management functions, especially enterprise-grade storage management functions like snapshots, can I do it in the same interface that I'm managing my application? Or for those functions, do I have to go outside and enable those? The goal for us is to enable those functions in the same interface, the same place where you're managing other application-level functions. Other pieces we're looking for here is, well, if you're running enterprise applications, especially stateful enterprise applications, how do you manage disaster recovery for those applications? Can I take backups? And what even backups means in that world? Is it code, data, and all together, or it's just parts and pieces at different rates? So one of the key goals is to enable backups in GCS, and then you can rehydrate them either on-prem or in the cloud, wherever you prefer is the right place for the workload and the application. Moving on, with any stateful application, one of the challenging parts is upgrades. How do we enable upgrades, and what happens before you take an upgrade? So being able to enable local snapshots of a stateful application, that's another set of functionality. And then, of course, security and role-based access is key to any enterprise-grade application, or be ready for even enterprise applications to come on board. Diving a bit more deeper, so if you look at GCP, how we enable data protection on GCP is you can take a snapshot in a multi-regional bucket or a regional bucket in GCS, and which protects us against either regional failures, zonal failures across. Now, the goal is to work with the partner community so that the backups can be stored in GCS. And depending on the data locality that the customer's service levels and the compliance pieces allow, you will be able to store those backups anywhere in GCS, either a regional, a multi-regional, or a specific bucket thereon. So it's a close collaboration with the partners and the cloud to enable the backup and restore functionality. Now, getting a bit around why we started to solve this problem and some of the data points we wanted to share as we're talking to more customers and partners. So with the evolution of Kubernetes, we've gone from a beginner and enthusiast phase into enterprise 1.0 and moving towards a 2.0 adoption, where customers are looking at Kubernetes not just for stateless, but also for stateful workloads. And part of the reason is they are looking for, can I have a consistent experience and a standardized platform for all my applications versus some different architectures for different applications. And it's a move towards that consistency and being able to take the advantage of Kubernetes extend to stateful applications. But again, as we get into it, some of the basic functions like key management, app consistent snapshots, being able to take cluster management, those are key areas that have to be addressed consistently across before we get to that. And as we move on, we're looking to add functionality around observability. If I have an SLO violation, how soon can I address that? Can I find all the moving parts and pin them down to say where is the choke point or how do I address that within a reasonable time frame? And last but not the least is getting into how do we enable management at scale with a rich set of UIs. Couple more data points around. There was a Google survey done for GKE customers. And there are a lot of customers, around 39%, that are looking for a standard lift and shift of applications. But if you look at the numbers, there is a larger set of customers, close to 59%, that are looking to modernize the applications on-prem and then move to the cloud as and when they become ready, versus kind of just moving in the cloud and using it as infrastructure pieces. So our goal for the Anthos storage is to address that need where customers are looking to modernize applications on-prem before they move to the cloud and start scaling or actually doing migrations, whatever the use case may be. Now, going deeper into what are the specific challenges that we see today with stateful workloads. And one of the key challenges we see is, for the most part, the storage that exists today is designed to be mapped to a host. And when you get into Kubernetes world, it's containers and applications. So bridging that gap has been a challenge. So that's where we're working with the partners to help enable bridge that gap in a much more standardized way. Next piece is, according to a survey that was done by Datadog last year, the biggest difference is also the average lifespan of a container. An average lifespan of a container is 2 days versus for a VM is 23 days. Now, in that itself, the data point is interesting, but what it means. What it means is that can I move my data at the same pace that my application is moving? Can I match that pace? And if I don't, what risk does it create? Do I have the backups? Do I have the restore points that if something goes wrong during that mobility, because it is so agile, can I restore my application back in a consistent state? So that's kind of a key to take away from how we are interpreting that statement. Now, getting into basic data lifecycle management. Can I create app consistent snapshots? When I'm running a DB inside, what does it mean to take an app consistent snapshot? Does it mean I take a snapshot of the data, and there is a separate chain to take a snapshot of code and config? Or can I take a consistent entity with code, config, and data and make a snapshot? So when I take a snapshot and I relocate it, I'm assured that I can rehydrate my application and no components are left behind. So these are some of the issues we really are seeing more and more common as customers are trying stateful applications with Kubernetes, GKE. Now, getting a bit deeper around what's our approach to solve this and how we're solving this. We understand storage is very personal to what workloads you're working on. It also depends on what partners you choose to work on given your workloads. So our intent is to meet you where you're comfortable with the vendors that you're comfortable working with. With that spirit, we're working with a large set of vendors, and listed here are some initial set of storage technology partners that we already started working with, and we're engaging to solve those use cases. But this list will grow over time, and our goal is to really meet with the vendors, with the partners that you're comfortable with, which match the workload that are deployed with the SLAs that you need for that particular workloads. So as we bring the partners on board, we really also want to create a level of comfort with by creating a certification process. And we're looking essentially as 4 different types of certifications or validations. One could be what we're developing is an open interface, and partners are welcome to write to that interface. But once they write, they can self-qualify it, and they can distribute it through their channels. The next phase is that we, as Google, test those drivers, those softwares in our lab to make sure they work well with Anthos environment and things work seamlessly. And at that point, they get a choice to say, should we distribute those through the vendor infrastructure, or should we distribute those specifically like software-defined vendors and also like drivers for appliance vendors? Should we distribute them through Marketplace, which gives customers a lot more seamless, unified experience? Eventually, as the program matures, we really want to get to a point where we are pre-packaging certain sets of drivers in the bundle, so that gives one less click or one less step for the customers, and the experience is a lot more seamless. With this, I'll invite Partha on the stage to talk more about some of the customer challenges and use cases.
Thank you, Manu. So before I get started, maybe it's a show of hands. How many of you are running stateful workloads on containers today or Kubernetes today? It's pretty impressive, actually. If you think about it, just last year, I would say that very few people would have lifted their hands, and this is actually an ongoing trend. Anyway, with that, so who am I and what am I talking about today and what am I doing here? So as a way of introduction, my name is Partha Seetala, and I'm the co-founder and CTO of Robin.io, and we are partners with Google on the Anthos platform. Now, a little bit about the company. So the mission of the company was to enable our customers to run mission-critical stateful workloads on containers and by extension Kubernetes. So when I say stateful workloads, what does it mean? I mean, it could be just a small Jenkins job with persistent volumes underneath it. But when we looked at the market, the real pain, if you will, was around the more complex platforms such as the big data platforms like Cloudera, Elasticsearch, Splunk, or of course the NoSQL platforms such as Mongo and Cassandra and Couch, and even traditional RDBMS solutions like Postgres, Oracle RAC, HANA, and all that, right? And it's kind of surprising if you look at it. Nobody really associates the word Oracle RAC with Kubernetes, but we have production deployments of that. So I think it's safe to say that we know a thing or two about how you can run these applications on Kubernetes and what are the real challenges that somebody's going to see when you actually manage them. The one point I do want to highlight is based on the experience of the type of workloads that we have been able to onboard onto Kubernetes, we have brought the expertise of how you take all of this stuff and then package it into a set of APIs that you have co-developed with Google to give to the community. And our hope here is that this would become like what SQL did to structured querying, this would do to data management on Kubernetes for stateful apps. And that is the thing, that we want these API sets to be something that a lot of other partners would also embrace. But what you're going to see today is the API specs and the demo of how it looks like. But before you go there, right, so what is so different about running stateful workloads? So why do you even have to talk about this as a main topic, right? So a couple of things here, right? So unlike a stateless workloads, which is very ephemeral, and the way you scale it is very different than, let's say, a database where you just don't add more pods and take them away because there are costs associated with data redistributions and all that. So that's on the deployment side. But once deployed, unlike a stateless application, a stateful one has a very long life. And people are used to doing data management on that. And when I say data management, it's usually around data protection, whether it is snapshots or backups, or it is around data collaborations along with their apps, things like clones and all that, right? But for the folks in the room who come from the storage background, these are not new terms. Everybody understands these things. But the world is very different today. In the previous world, all these things were usually done by the storage administrator. In today's world, in the Kubernetes world, it's done by developers and DevOps, and they are not necessarily storage experts. And it's very hard for them to comprehend what it means to go snapshot a LUN and what it means to go and clone it, right? So what you really need to do is elevate this entire experience into an application construct so that developers can go and say, I have a Mongo that I have spun up either through an operator or through Helm. I'm going to go snapshot it, or I'm going to back it up, or I'm going to port it from one data center to the other. Now, I'm going to go a little deeper into what it means to do those things, and I'm also going to use a few of our real-life customer experiences and what pains the customer had and how we had solved them. So the first thing is around data protection. So you want to basically keep a copy of your application and its data in such a way that if there is a corruption, you can easily roll back to a more cleaner, pristine state. Now, there are two ways to do it, and it's very important to kind of capture both of them and kind of talk about the differences. There's this notion of snapshots, which is usually a way in which you can snapshot your entire application on the same disk on which it is, from which it is serving out the data. And then there is a thing called backup, where you basically take these snapshots and then move it up into the cloud. So both of them serve two different needs, right? However, if you look at today's challenges, the way you would do this, let's say you're running, just take a very simple example, Postgres, right? If you're doing Postgres today, you would have to go and tell your storage administrator that, hey, listen, I got to snapshot my storage LUNs. They would snapshot that. But then what? You just have a snapshotted LUN. What the developer would want to do is they would want to go and snapshot not just the storage volumes, but all the metadata around that storage volume, which would be obviously the PVCs, then things like config maps, then stateful sets, services, secrets, all of that, because all of that essentially forms your application. And once you can capture that as an application snapshot, then you can enable workflows such as creating a quick clone or migrating it to a different data center and things like that, right? The next one is around clone. So maybe a use case from one of our Oracle RAC customers. So it's a large travels bookings company. They run Oracle RAC as a service on Robin. And one of the use cases that they have is their DBAs, at the end of every quarter, they have to run reports. And they don't want to go and run those reports on the production database. So what do? They go to this platform and they say, I want to create a very quick clone. And when they create a clone, it's not, again, as I said, it's not a storage clone. It is a fully functional, running Oracle RAC instance with data as of a previous snapshot that was taken. Another use case for clone would be to validate patches and upgrades. Nobody wants to go and run a patch or an upgrade on the production database. Ideally, you would like to create a clone, run it there, validate. If everything is fine, then you would go and apply it, right? So those are the kind of use cases that you can enable and make it much more easy to consume in this world of Kubernetes by elevating this entire experience to applications. And the last interesting use case that I would like to capture is app portability. And what I mean by that is more and more you see that developers want to liberate their applications and data from the underlying infrastructure choices. You might start today on premises, let's say, or in AWS, but you would like to go migrate tomorrow into Google Cloud because you have resources there that you really want to use. Maybe you want to use TPUs there, right? So you want to have the ability to go and migrate your entire application, not just the storage volumes. And that's incredibly difficult because each data center, each cloud has a different way in which that does storage and networking and all that. So you've got to abstract it out in such a way that you can very easily migrate things. Now, so with this, I mean, these are the kind of experiences that we have been able to give to our customers on Kubernetes. And this is the experience that we have shared, and we have co-developed this APIs with a deep integration with the Anthos storage team. So what does it mean? How would a partner's life look like once you have embrace these API sets? So I'm going to show you what we have done at Robin. So let's look at this on the left-hand side before today, maybe, right? Before you hear what I'm going to say on the right. The way you would deploy a stateful workload is either you would use the standard kubectl interface and use YAML, or you will use a Helm chart to deploy it, or you might use an operator if one exists, right? So this is nothing different. This is very standard way of doing things, but this is just provisioning. What you need beyond this would be something like this, right? Where you can go and do an entire snapshot of your Postgres, let's say Helm release, right? Or a running instance of your operator. Or you can clone it. You can push it from on-premises to GCS, right? And then from GCS, you'll be able to drain it back into a different region. So think about the power of this, right? GCS is an object store. Postgres sits on a block store. So what you're doing here is from one data center or one region, you're taking a snapshot, you're pushing that snapshot from block, the snapshot sits on block, you push the snapshot from block into GCS, which is object, and you can go to a completely different region. And using GCS's global distribution, right, of objects, you can go to a completely different region and rehydrate this data from object into block. and offer it up as an application, running application. Now, imagine the power of this, right? So that is what this API set is going to do. And we're hoping that this does truly become the sequel of data management. And we are very honored to be part of this effort with Google. With that, I'll hand it off to Oleksiy for showing you a demo and going into the technical details.
Thank you, Partha. Hello, my name is Oleksiy Stashok. I'm a software engineer in Anthos storage team. And okay, I'm gonna stay. I think I have a mic here. There you go. Okay, so let's take a look at the architecture, the high-level architecture. So here you can see that we introduced a couple of new components to Kubernetes, and every component is represented by this red block, which is a component controller, and the arrows pointing towards that block represent API for the controller. APIs are defined as Kubernetes custom resource definitions, CRDs, and you can notice that these components are nicely layered, one on top of the other. So the component on the top can leverage functionality of the component on the bottom. So let's take a look at the individual components. So the volume group controller and API is responsible for taking crash consistent volume group snapshots and backups. It talks to CSI driver to run some storage level commands like take a snapshot, create a backup, restore a volume from the snapshot or backup. And it uses GCS. It uses GCS to store, to export the backups. So the next component is application controller and API. And application controller and API are responsible for taking application level, application consistent snapshots and backups, which include both persistent data and application metadata. And we use an application backup management service to keep as a global registry for our backups, so the backups could be used across different Kubernetes clusters. And the third component is application policy controller and API, which is responsible for scheduling and retention, application level snapshots and backups, given some policies. Okay, at this point, I wanted to just step back and explain how we model our APIs, what is the API structure, and what is the responsibility of each piece of the API. So we model our API the same way as Kubernetes models persistent volumes and persistent volume snapshots, which means we use controller, claim, and content triplets. So, where class provides portability across clusters, and it refers to the specific controller or handler to handle claims, and it also contains some configuration for controllers, say some secret keys or something like opaque parameters for controllers. And class usually is provided by Kubernetes administrators. The next one is a claim, which is provided by user, and actually it's a request for action, like take a snapshot, create a backup. And the content is the actual result of the controller processing the claim. So like snapshot was taken, and here is the snapshot ID. Okay, so in this demo, we'll be mostly talking about application component, and now we are gonna I'm gonna explain the components API and CRDs we use in this component. So first one is StatefulApplication, which defines an application which has some persistent state. You can use this CRD when you want to just refer to your existing application, and later you can refer to the stateful application when you take snapshot or backup. Or you can create stateful application and refer to existing snapshot or backup in order to controller to actually provision an application based on the snapshot and backup. The next one is application snapshot, which represent the application snapshot like state stored in the local storage. And when we say state, it means it both persistent data plus metadata. This CRD can be used in two cases. When you want to actually snapshot existing application in your cluster, or if you want to import external backup to the local storage. Application backup. It represents the application state stored in external storage, like GCS, for example. Again, here we are talking about state, which is represented by both persistent data plus metadata. And application backups are used either to back up a running application or in order to export the local snapshot to external storage. Application rollback defines a user request to just roll back existing application to a previously taken snapshot or backup. OK, here comes the demo. Can we go back to slides? Thank you. So I just wanted to touch upon the use cases which we're going to cover in the demo. So first use case is rollback an application after unsuccessful upgrade. And the second one, we're going to migrate the stateful workload from on-premise Kubernetes cluster to the cloud Kubernetes cluster, which is, in our case, GKE. The demo setup. So we actually have two Kubernetes clusters. One is running on-prem by GKE on-prem. And we run it on VMware and use Robin as a software-defined storage. In the cloud, we use GKE as a provider of Kubernetes cluster. And we also use Robin software-defined storage for running on top of persistent disks. Our application consists of two components. Is the UI, which for simplicity we represent as just simple SQL path application, which is just web-based SQL tool. And persistent state is stored in Postgres, which you run in master-slave mode. And just to maybe add you some color about the application, so let's assume this is a sales application we run for our company's sales. But for the purpose of the demo, we'll only take a look at the part of the application which is responsible for handling customers. OK, with that, we can switch to the console. Thank you. OK, so now I'm in the console, where we console on-prem, which you can tell by this little blue arrow at the bottom. I will switch from the on-prem to the cloud when we need it for the second use case. I prepared a set of scripts, bash scripts. Mostly they are only it's just they wrap kubectl commands. So before running every script, I'm going to show its content. So we are on the same page and explain what does it do, what it does. And yeah, so let's take a look at the application, which is running in the on-prem cluster. So we see, as I mentioned, is a sales application, which consists of two parts. The first one is the Kubernetes, Postgres, run in master-slave mode, and the actual UI we have here. So let's take a look at the UI and the content and what we have and the data we have in the database. So we have a customers table, which has, for every customer, we have first name, last name, email, and company. So let's run some prerequisites first. Prerequisite script. Let me show you what it has. In this script, we just deploy application snapshot class and application backup class. In the snapshot class, we define that Robin is going to handle the snapshots. And we say that, and here we defined also application, Postgres, QS, and unQS hooks. So we are able to take application consistent snapshots. In the backup class, we defined just the backup handler, who's going to handle our backups. OK, let's run the script. So the next step would be we have a running application. Now let's create a stateful application on top of it. So we are going to run the second script where we define the stateful application, and we refer to the sales application which we are currently running. So now we're going to wait a little bit until controller sees that request and fulfills it. OK, so we are registered stateful application with the controller. OK, so now it's time for the first use case. It's rollback after unsuccessful upgrade. So yeah, so here's the story. Assume you have like PM coming, approaching you. Like PM, let's just say like Manu asked me to specifically say it's not him, so it's not Manu. Yeah, so we are on the same page. Yeah, so where was I? Yeah, so Manu approaches me and says like, OK, so a sales team has new requirements, and they want actually to extend the way we maintain the company's data. So now we have company name only as a part of the customer, but they want to actually extend that functionality and maintain more information about company. So, and I said, yeah, that's cool. I need 3 days for that. He says, nice, you have 1 day. I got to go, bye. OK. Now we have 1 day to actually do 2 changes, right? We need to change UI, and we need to actually provide a change to the database schema. So we can extract the from customer's table, we need to extract the information about company and put that into a separate table. OK, so I prepared an upgrade script for that, but considering we didn't have much time for testing, right, and it's like database schema change is usually pretty dangerous, so we are going to take a snapshot first of the existing application. Let me show you what we do. So we are creating an application snapshot and refer to the application, the stateful application which we are currently running, which we registered in the previous step. OK, so controller started working on it. So just to stress it, so when we say like take an application snapshot and take an application backup, we are talking about both persistent data and metadata. OK, snapshot is ready. Everything's ready for the upgrade. So let's do the upgrade. OK, this is our current state of the application. As you see, we use UI version 1, and we're going to upgrade it to version 0 to version 2. And here's the rest of the application. So yeah, we are ready to continue. Here's the script which will perform the actual database upgrade, schema upgrade. So are you sure? Yes, I am. OK, let's wait for the upgrade. It's going to be ready soon. Done. OK. So now please notice that we have UI version 2.0 running. And let's give some time for the application to settle down. So it's still like UI is terminating. Come on. Yeah. OK, so upgrade. I would say it was successful, right? No error. Let's take a look at the data. Right, you can see that now we have 3 tables, not only 1. So let's take a look at the companies table. Right, so company names were like successfully transferred from the customers table to the new table. Let's take a look at the customers. OK, yeah, please notice what happened. Instead of, like during upgrade, instead of extracting the company and then deleting this column, I actually deleted the email column from the table. But fortunately, we have our snapshot, right? So now we are able to roll back our application to the previous state, fix the upgrade script, and run it again. So now let's roll back the application. So I'm going to run this script, which defines a rollback, points to the sales stateful application, and as a source says use a snapshot, which we took on the previous step. So let's do the rollback. So the rollback will take a little bit longer because as a rollback, as I understand it, it's complete full application rollback, including its like pods and everything, because metadata was also stored. So as part of this upgrade, we will again switch back from UI version 2 to UI version 1. So now you see that all the pods are terminating. So we need to wait until they are all terminated, and they will be replaced with the snapshotted version of these application. So UI is always behind, so we need to do something with that. Okay. Done. So the new version is terminated, and now you'll see that the older one, the snapshotted version, will actually start spinning up. And here, okay. So please know that now UI is version 1.0, so it's a previous version of our UI. And soon we're going to have all the pods running and ready, and so we can go back to the database and see what's in there. Okay, let's take a look at the database. You see now we have only one table. And all our information is back, so including emails. So now we can fix the upgrade and run it again. So this concludes our first use case, and the second use case is going to be migrating of stateful workflow from on-premise Kubernetes cluster to GKE. So as a first step, we need to actually, now we have a local snapshot, right, we took before the upgrade. Now we need to actually make this snapshot available for the external cluster. For that, to do that, we actually export this snapshot to including data and metadata to GCS using this script. So we are creating application backup. As a source, we provide a snapshot, which we took on one of the previous steps. And the target location, we say it's GCS bucket, and the secret we provide to give controller access to the bucket. So let's run the script. Usually taking backups may take time because it's like we transfer data from local storage to the remote one. But in our case, we don't have a lot of data, and usually storage providers, they support incremental backups, which means once you uploaded like full backup, the next next updates to the backup will be just incremental, so only deltas will be sent. So done. So okay, the backup was exported. And we have this backup ID, which we'll need later to actually import information about the backup on the GKE cluster. Okay, let's switch to GKE. I'm going to switch the kubectl context to GKE. Done. Let's take a look what we have in GKE cluster. Nothing. That's good. That's exactly what we need. And yeah, so the first step, now when we are in GKE cluster, we want to import knowledge about the external backup to internal Kubernetes cluster. So for that, we'll need the ID. Actually, let's take a look first at the import script. So as you see, we are going to create the application backup, which refers to the external handle. It's the ID we obtained on the previous step when we exported the backup. And as a location for where we take the data is GCS bucket, which is the same as on the previous step. So let's copy the ID from here, from the on-prem, and let's go to the cloud and run the script. Okay, so now we see that information about the external backup was imported successfully and pretty fast. The reason that it's so fast because we don't actually import data, we import only knowledge about the backup. So, and on the next step, we are going to actually rehydrate the stateful application from the backup. So I'm going to run this script, which will create a stateful application, and I specify the source, I specify backup, which this cluster already knows about, and I just say create this stateful application on top of that, based on that. Okay. Oh, so now we see that application is being imported. So, and we can notice that it's UI version 1.0. It's the same one we use for the snapshot. And yeah, let's wait for the actual cluster to application to become ready. Yeah, my GKE cluster is behind firewall, so I don't have direct access to nodes of the GKE cluster. So for that reason, I'm going to need to do some SSH forwarding, port forwarding. I'm going to use this node port to forward it to my local machine. That's not the one. Wait, no, I think it's here. Okay. Yeah, so basically I forward this port, which we took on the previous step, to the local port 20090. Okay, it's done. And let's go back to the cloud and see. Okay, so imported. So application is up and running. Let's take a look at the data. So it was port, different port. Okay, something's there. I'm going to use cloud and select from customers. Yeah, unfortunately, there is some issue with networking in GKE. I saw it previously, but I know how to fix it. So that's a good news. We just need to bounce a UI, and it's going to work. So I have a script here, which just says restart cloud demo UI. So it's just what I'm doing here is just basically bouncing the demo app UI. It's also possible. Okay. Yeah, let's now see it again. let's try one more time. And there is another keyword to that. It's not talk to the service, but talk to the pod directly. So I'm not even we'll need to fix that in GK. Okay, so yeah, so it's just intermittent networking problems. Yeah. Yeah. You saw it, yeah, that was. Yes. So yeah, sometimes it didn't work even when I was, at home, doing the demo. So I'm not surprised it doesn't work before such large audience. So it's kind of expected. Yes, that's a good point. I forgot about that.
I agree with that.
Okay, yeah, thank you.
Perfect. Thank you so much.